All right, guys, so before we went on Thanksgiving break, we had Chapter 4, Green Book GB, Chapter 4 over the matrices. If you have not got those assignments turned in, you do have till the end of the semester to get those turned in. So, if you did turn them in at this point, they're most likely graded unless you turned them in today. I haven't got a chance to grade anything from today. Okay, you can put it on my desk. Today we are starting Chapter 4. This will be the last chapter we cover before Christmas break. This is the last chapter we're covering this semester. Chapter 4 is going to be polynomial functions. Quadratics, what we did in Chapter 3, all of those are a type of polynomial function. But we're going to be looking at degrees or functions that are bigger than it. So x squared is not going to be the biggest exponent, because we can have degree 3, 4, 5, 6, and going up. And the degree tells us what type that function that we have, and it's based off the equation. Now, the first type of polynomial function we have is called a constant function. It's just a number. It has no variable. Its degree is 0. We get the degree from the variable with the biggest exponent. Constant 0. So our linear function, our variable with the biggest exponent would be x, or x to the first. So it tells us our degree is 1. Which means it's a linear function. It's an equation of a line. 5x minus 7 would be a linear function, equation of a line. Our next example we have is 2x squared plus x minus 9. So our term with the variable with the biggest exponent is our 2x squared. X squared tells us that the degree is 2, meaning it is a quadratic equation. Our next one, though, we have x cubed minus x squared plus 3x. Well, x to the third power, x cubed, is our monomial term with the biggest exponent. And that x to the third tells us that the degree is 3. And since the degree is 3, it would be a cubic. And lastly, x to the fourth plus 2x minus 1. X to the fourth tells us that the degree is 4. And it is a quartic. Degree 4 is quartic, degree 3 is cubic, degree 2 is quadratic, degree 1 is linear, and degree 0, we don't have a variable, is constant. Really, we do have names for functions that are bigger than degree 4. Degree 5, I believe, is quintic, but we really don't start naming them, at least in here, beyond that. Questions on degree and type. So that's really what this is looking at. Now, two big things with polynomials. One is standard form. Writing the polynomial in standard form is writing it in order of decreasing powers from left to right, with the biggest power going first and then decreasing all the way to our constant. And if it's not written in standard form, we need to write in standard form, because a lot of stuff that we do, having it in standard form is going to be very helpful in solving and doing other stuff. And the other piece is leading coefficient. The leading coefficient is the number in front of the variable with the biggest exponent. It's the leading coefficient because it's going to be the first term. So that number is going to be leading the first expression, our first monomial term. It's the leading coefficient. Really, any number in front of a variable is a coefficient. The leading coefficient is the number in front of the variable with the biggest power. Questions on this so far? All right. Now, the next thing we want to look at is, what is a polynomial function? Is it a polynomial function or a polynomial expression? And I found the easiest way to be able to determine if it is going to be figuring out what it's not. What properties will it not have? The first thing, exponents aren't negative. Our exponents attached to variables are not negative. So what that means is that we cannot have x to the negative third power. So the exponents attached to variables aren't negative. Now, we can have a negative exponent attached to a number, that's fine, but it cannot be attached to a variable. I cannot have x to the negative 3. I can't have x to the negative 1. We cannot have exponents attached to variables that are negative. Exponents aren't fractional, so we can have 2 to the 1/4. I cannot have x to the 1/4. Our variables' exponents cannot be fractional. So the exponents attached to variables cannot be negative. They can't be fractional. So we can't have x to the -3. We can have 2 to the -3. We cannot have x to the -3. Our third one, exponents aren't variables. I cannot have x to the y or 2 to the y or 2 to the x. We cannot have a variable in an exponent. The main reason behind this is because if we have 2 to the y or x to the y, it's actually exponential. Those would be considered exponential functions. Really, fractional exponents, so x to the 1/4 is actually a radical function. Negative exponents, so x to the -3, that's just 1 over x to the 3rd, because that's how we make exponents positive, which is rational. We're good with the first 3. Variables aren't inside radicals. We cannot have the square root of x, the cubed root of x. Numbers, that's fine, because the cubed root of 8 is just 2. It's a number. We cannot have a variable inside of a radical. We also can't have variables, different variables being multiplied together. I can't have x times y. That would not be a polynomial function, a polynomial expression. We can't have variables being multiplied together, and variables cannot be in the bottom of a fraction. We can't have 1 over x. So the top ones, exponents aren't negative, especially mainly attached to variables. Exponents aren't fractions attached to these variables. I can have negative exponents attached to numbers. I can't have them attached to variables. We can't have fractional exponents attached to variables. We can numbers, but specifically variables. Questions on this here? Yes. All right, we ready for the first one? F of x equals -2x cubed plus 5x plus 8. So we want to first determine if it's a polynomial function or not. If it is a polynomial function, we want to write it in standard form. State the degree, type, and leading coefficient. So if we look at this here, -2x cubed plus 5x plus 8, do we have any negative exponents attached to variables here? No. Do we have any fractional exponents attached to variables? Nope, so we're good there. Do we have variables in an exponent? Nope. Do we have any variables inside of a radical? Are variables being multiplied together? Well, no, x cubed would technically be it, but we're looking for mainly 2 different variables, x and y, 2 different terms. So no. And do we have a variable in the bottom of a fraction? No. So can we say this is a polynomial function? Well, yes, because all of those, it did not make any of these false. We did not have any of this here. So it is a polynomial function, which means we can write it in standard form. Standard form says we take whatever variable has the biggest exponent and put it first. Well, for us here would be our -2x to the 3rd. X to the 3rd is the variable with the biggest exponent, so it would go first. The variable that would follow would be x squared. Do we have an x squared term here? Nope, so we don't have to list it. Then it'd be x to the 1st, which would be our positive 5x, and lastly our constant term, our term without a variable, which would be plus 8. So realistically for this here, it's already written in standard form. We didn't have to do anything to change it. Now we need to find the degree. And what would the degree for this here be? Three. Because the biggest exponent attached to a variable is 3, so the degree is 3. Now that we have the degree, we can actually tell what type it is. And the type would indeed be cubic. Because the degree is 3 and the type is cubic. Any questions on this here before we find the leading coefficient? I abbreviate it as LC. And what would the leading coefficient for this here be? What the leading coefficient would be? The leading coefficient is the number in front of the variable with the biggest exponent. Negative 2. So looking at A, is there any questions on how we write it in standard form? Find the degree, type, and leading coefficient. Now before we look at B, we're going to look at C. We're just going to go straight down. H of x equals negative x squared plus 7x to the negative 1 plus 4x. And the first thing we want to do is determine if it's a polynomial function. So I just go from the top to the bottom. Do we have any exponents attached to variables that are negative? Yes, because we have this 7x to the negative 1. So what that tells me is that this is not a polynomial. It's not a polynomial function. Not a polynomial. And we're done. Because if it is a polynomial function, then we're going to write it in standard form, state degree, type, and leading coefficient. Since it's not a polynomial function, we don't do any of that. It's just not a polynomial. Question on C before we look at B. Let's look at B. G of x equals negative 0.8x to the third plus the square root of 2 times x to the fourth minus 12. So let's look through our different things for it to be a polynomial function. So looking at this here, do we have any negative exponents attached to variables? No. Do we have any exponents attached to variables that are fractions? Well, no. Do we have any variables in an exponent? Well, no. Do we have any variables that are inside of radicals? It looks like we might. The square root of 2x to the fourth, yes? Does that radical bar go all the way across x to the fourth? No, it stops at the 2, so the variable is not necessarily in the radical. It's next to it, it's being multiplied by the square root of 2, but it's not actually in the radical. If it was, then it wouldn't be. But since it's not, we're fine there, because if it was, it would look more like this here. That bar would extend out over the x to the fourth, showing that it is indeed inside. So we're good there. Do we have two different variables being multiplied together? No. And we don't have variables in the bottom of fractions, so is this a polynomial function? Yes. Is it written in standard form? No, because we need that x to the fourth term to go first. So we'd have the square root of 2 times x to the fourth first. Now our x cubed term would go second, so minus 0.8x cubed, because that would be our second term. The next term would be our x squared term, but there's not an x squared term, so we don't list it. Our term after that would be our x to the first, or just x. We don't have it, which tells us our next term is our constant term, so minus 12. So in standard form, it should be the square root of 2 times x to the fourth minus 0.8x cubed minus 12. Now our degree for this here would be 4. Degree would be 4, our x to the fourth, fourth power. Now the type, quartic. And leading coefficient would be square root of 2. We can have numbers inside of radicals. We cannot have variables inside of radicals. Questions on C? D, k of x equals x squared plus 3 to the x. Can we say this is a polynomial? Variables cannot be in an exponent. So the 3 to the x tells us that this is not a polynomial. Not a polynomial. That 3 to the x is actually an exponential function. So it's not going to be considered a polynomial function. Questions on A through D? Now, because it's not a polynomial function, we don't have to write it in standard form, state the degree, type, and leading coefficient, because it's not a polynomial. Let's look at 2 of these here, and then we'll move on to the next part. We can look at number 1. F of x equals 7 minus 1.6x squared minus 5x. Can we say that this is a polynomial function? Yeah, if we're not sure, we can go through the list. We don't have any negative exponents attached to variables. We don't have any fractional exponents attached to variables. Variables are not in an exponent. We don't have radicals at all anywhere in the equation, so that's good. We don't have a variable inside of a radical. I don't have 2 different variables being multiplied together, and a variable does not show up in the bottom of the fraction. So yes, we can say that number 1 is a polynomial function. Now, to write it in standard form, we need the variable with the biggest exponent to go first, which is our x squared term, telling us that the first monomial term that we have is negative 1.6x squared. Then we'd have minus 5x plus 7. So our x squared term, our x term, our constant term. Now from here we can find the degree. And the degree would be 2. Because of the x squared. Now the type would be quadratic. And lastly, the leading coefficient would be negative 1.6. It's not just 1.6. We do need the negative sign. Question on number 1. Let's look at number 2. Can we say that x plus 2x to the negative 2 plus 9.5 is a polynomial function? So why would we not? Negative exponent. We have a negative exponent attached to a variable. It would not be a polynomial function. So we feel comfortable with identifying polynomial functions. And if they are polynomial functions, degree, type, and leading coefficient. All right, we ready for the next part? Evaluate f of x equals 2x to the 4th minus 8x squared plus 5x minus 7 when x is equal to 3. So what this is asking us to do is to replace every x with 3. saying take this function here and replace every x with 3. Find out what is the value of this function when x is 3. And especially on the ACT, if it tells you to evaluate a given expression, a given function for a value, plug it in. Because really all we have to do for this here is we can take the calculator and say 2 parentheses 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. And it tells us that it is 98. And that's it. That's all we have to do for this here. Yep. Now, for the most part, if you do struggle with evaluating expressions or evaluating given expressions for terms or after we plug it in simplifying, that's fine. Plug it in the calculator, let it do it for you. Because if you do struggle with it, that is perfectly fine. I hope you don't, but again, if doing order of operations was not a struggle for most, the number of memes that are out there would not be as rampant as they are. Simplifying this and how that always it's on every social media that's ever existed, where they tell you what the values are, and a lot of times a good number of people get them wrong, especially giving division and multiplication. But this is 98. Don't want to do this for -4, or not -4, but 4. So if we wanted to evaluate this for 4, we're going to say -2 times 4 to the 4th plus 6 times 4 cubed minus 3 times 4 plus 11. So plug this in and see what you get. Yep. Either one. And when we type it all in, we should get negative 129. It might be good to make sure you have one out. So especially when we start graphing or doing other things with the calculators, so we can work through it together. So you get some practice with typing these. And, yeah. Because 7 squared is 49. 2n times 2n is 4n squared. We're just simplifying it using the difference of perfect square formula. And unfortunately, you can't type variables in here because n has a specific value, and most likely n is set to be 0. Possibly. Questions on evaluating? Do we feel comfortable with evaluating? Because even if we looked at number 5, 3, x to the 5th minus x to the 4th minus 6x plus 10 for -2. Because at this point here, we can type this whole thing in. Four, 8, 16, -32. -2 to the 5th would be -32. -2 to the 4th. 4, 8, would be positive 16. Negative 6 times negative 2 would be plus 12, plus 10. 3 times negative 32 is going to be negative 96, minus 16 plus 22. Negative 16 minus, negative 96 minus 16 would be negative 120, plus 22, 0, negative 90. We can check and see here. To the fifth, minus negative 2 to the fourth, minus 6 times negative 2. Make sure that you didn't put everything into the exponent.
I don't even know how to check this.
So what you did, instead of putting the minus between, so negative 2 to the fifth minus that next term, replacing each one of those minuses as negatives, the calculator is going to say you're multiplying. So it's it has 3 times negative 2 to the fifth times negative, in parentheses, negative 2 to the fourth times negative. So it stuck a multiplication in between each one of those instead of subtraction. That's why the number got so big. Questions on evaluating? Okay. Now the last thing we're looking at today is end behavior of a function. End behavior says that as we take a function and we plug in bigger values and smaller values, as we keep going to the left and to the right, how is the function going to behave? How is it going to work? And no matter what function is, no matter what the degree is or the leading coefficient value is, it's going to behave in one of 4 ways. Even degree functions, they're either both going to go up, end up going up, or both going to end up going down. Now, a lot of stuff can happen in the middle, going up and down, but eventually, with an even degree, they're both going to end up going up, or both ends are going to go down. What happens in the middle will change from function to function, but they will either both end up going up or both end up going down. And the way we determine that is based off of the leading coefficient. So if the degree is even and the leading coefficient is positive, we say that the end behavior is defined as such. F of x approaches infinity as x approaches infinity. As x gets bigger and bigger, the y values are going to end up going up to a positive infinite value. They're going to infinitely increase. F of x approaches infinity as x approaches negative infinity. As we go to the left and get smaller and smaller values of x, the function is going to go up. Both values are going to end up going up eventually. The same is true, or similarly, if the degree is even and the leading coefficient is negative, the y values are going to end up going down. F of x approaches negative infinity as x approaches infinity, and f of x approaches negative infinity as x approaches negative infinity. They're both going to go down. And with odd degrees, the function is going to go in opposite directions. It's either going to increase to the left and decrease to the right, or decrease to the right and increase to the left, depending on the leading coefficient. So, if we want to describe the end behavior for this function here, the first thing we need is the degree. And the leading coefficient. So negative 0.5x to the fourth plus 2.5x squared plus x minus 1. So what would the degree be? 4. And what's the leading coefficient? Negative 0.5. So our degree is 4, which is even. And the leading coefficient, negative 0.5, would be negative. So even degree and negative leading coefficient tells us what the end behavior is going to be. So at this point here, I would go back to our chart and look for even degree and negative leading coefficient. Not the chart, but everything else is going to be our answer. So it tells us that the end behavior for this here is that f of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. So really what that's telling me is that the y values are going to decrease. They're going to go down. No matter, it might take a while going to the left or right, but eventually both sides of the functions are going to go down. They're going to decrease. Questions on this here? Now, I already went on and graphed this. I did this in the graphing calculator, had the graphing calculator pull this up. This is the graph of this function here. But according to end behavior, it says both sides of the function should be going to negative infinity. Is that doing that there? Well, yes. So it's telling me that most likely all the solutions, all the places it crosses the x value are listed. If we said that the leading coefficient wasn't negative, it was positive, essentially that means that the function should be going up. But if it was positive and we get a graph like this here, that means as we go left and right outside the screen that's shown, the function should come back up. And our solutions are zeros is where it crosses the x-axis. So it should be telling me, I should know from end behavior that there should be another zero. There should be another location, another solution outside the picture that's shown. That's the big thing with end behavior. It gives us an idea, it gives us a picture of what the graph should look like. How should it behave as we increase to the left and increase to the right. But here, since the degree is even and the leading coefficient is negative, both sides should be going down. They are indeed in going down, which most likely means that we do have all of our zeros. I shouldn't expect it to make a turn and go back up. But for this here, this is all it's asking for. Questions on this here? Describe the end behavior of this function here. Well, the two main things we need are degree and leading coefficient. So the degree for this function would be 3. And the leading coefficients are negative 0.3. Well, 3 is an odd number, negative 0.3, well, that is negative. So the degree is odd and the leading coefficient is negative. So we look at odd and negative. And it tells us that f of x approaches positive infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. And which one we put on top and which statement we put on bottom really doesn't make a difference. We just need to make sure we have both of those statements listed. Questions on this here? So really all we have to do is figure out, is the degree even or odd? Is the leading coefficient positive or negative? And then line up which one of the four it is. You ready for the last one? F of x equals 0.25x cubed minus x squared minus 1. So the degree is 3, telling us that it is odd. The leading coefficient is 0.25, which would be positive. So now we're looking for the set of end behaviors for odd and positive, which would tell me that f of x approaches negative infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. And that's it. That's all it's asking for. Questions on these here? Questions on anything we've done so far? Problems 3 through 9. Determine whether the function is a polynomial function. If it is a polynomial function, state degree, type, and leading coefficient. And make sure it's written in standard form. 9 through 14. 9 and 10 is that error detection, so there is a problem with their statement. 1, describe what it is, and 2, fix it. So what they're asking for both of those is kind of like what we did 3 through 6. Determine if it's a polynomial function. If it is, say degree, type, and leading coefficient. 11 through 14, evaluate the function for the given value of x. They give you a value of x, you plug it in, tell me what the value is. Yeah, that's part of 9 through 14. And 17 through 19, describe the end behavior. What we did at the end of those last 3 problems. And that is it for 4.1.